Welcome to the class. This session is about the discussion on access to non-local data on the stack. That is, in this section, we are going to consider how the procedures access their data. And here we are going to see access to non-local data. So which means here especially here we are going to use the mechanism for finding the data that is used within a procedure but does not belong to procedure. Okay, so that is here we are going to access the data that is not local to the procedure, so which is present outside the procedure. We already know that the variables can be of either a global variable or it can be a local variable. So when a variable is said to be a global variable, when it is declared outside the function, then we can say that the variable is a global variable. And when we have variables that is inside the function, then we can say that the variable is a local variable. So here we are going to discuss about non-local variable. That is, we can also say that it can be a global variable, right? And now we'll start the discussion with the topic, that is data access without nested procedures. So here we are going to see how a procedure is going to access the non-local data if it is not nested inside another procedure. So when we take the C languages family, okay, the family of C languages doesn't support this nested procedure. So that is, we cannot define a procedure within another procedure. For example, there is a function like this, and inside the function we may have a function call inside another function, but there will not be any function definition that is inside another function. So this is called as nested function, or we can say nested procedures. So there this C family languages does not support this nested procedures, that is a function definition within another function. So here we are going to take an example that doesn't contain a nested procedure. So that means a normal C program which doesn't contain any procedure that is inside another procedure. So here the variables are defined either within a single function or that can be defined outside any function. So which is called as the global variable here. The the variable that is declared outside the function is called as the global variable. And as I mentioned, it is impossible to declare one procedure inside another procedure. So the global variable has the scope and it consists of all the functions, that is the functions that is that can use the global variables anywhere in the program, right? So that is what the global variable here, and it has the scope that consists of all the functions and the functions that follows the declaration of the global variable. If there is any local variable with the same name of global variable, then at that time that procedure can't access this global variable. Why? Because it already have the local variable with the same name, right? So it can access that local variable instead of this global variable. Otherwise this global variable can be accessed by any function in the program. So when we are considering the languages which is not supporting this nested procedure declaration, then the allocation of storage for the variables and access to these variables are very simple here. So whenever there is a language which doesn't have the nested procedures, then for that kind of languages the variable allocation and the access to those variables is very simple. And here we can see whenever we have a global variable and this global variables are allocated static storage. So here we know the classification of storages, right? So it contains static storage, then it has stack allocation, then it has heap allocation, heap area, right? So these are all the storage areas we have, and these global variables are allocated static storage. Why? Because during compile time itself the global size of the global variables are fixed, right? So which remains fixed until throughout the program, and this size can be known during compile time itself. So access to this variable is also very simple, so that we are using this static storage. And for the local variables, okay, when we have a variables that is inside a procedure, and for that local variable we are storing the storage allocation is the storage allocation is happening at the stack. Why? Because the stack contains the activation record, and that activation record contains the information about a procedure. And when that activation record will created, so when a procedure is begin to execute, then at that time the activation record will be created and stored inside the stack. So here the stack holds the local names. Okay, there is local variables of that procedure with the help of this activation record, and these can be accessed through the pointer top sp. So this pointer is used to access the local variables of the stack, that is inside the stack. Then we'll see what are all the issues with this nested procedure. That is, whenever we are using some nested procedures, there are some issues or the complications that we have, and we'll see what are all those. So whenever we are using nested procedure, the first issue or the first complication that we can face is accessing the declarations of procedures. So whenever we have a nested procedure, at that time the access becomes far more complicated. So the procedure declarations are also nested here, and this uses normal static scoping rule. So this becomes more complicated. So the reason for this complication is that we know that at compile time the declaration of P is immediately nested within Q, and when this is the case, it does not tell us the relative positions of the activation record during runtime. So that is, for example, we have a procedure Q and we have a procedure P. So this P is actually nested inside this procedure Q. Okay, so if this is the case, then we cannot find the relative position of activation records of these procedures during runtime. So that is why it is not possible to access the variables easily. So at this time, finding the relevant activation of Q from an activation of P is a dynamic decision. So it requires some additional runtime information about these activation, that is when P is activated and when Q is activated. We don't know that the P and Q may also be recursive. Okay, sometimes it can be recursive, so we cannot decide, or we cannot find the activation of P and Q. That is so for that purpose, here we have one possible solution for this problem, and that is what we are going to use access link here. So we'll discuss about that access link later. Now we'll see the language with nested procedure declaration. That is, what are the language that we can use for this nested procedure declaration. As mentioned, the C family does not support this nested procedure declaration. So again, there are some other languages that supports this nested procedure declaration. And if we look at the previous languages, okay, Algol 60, then we can say Pascal. Okay, so these languages actually have this nested procedure declaration concept. And now the latest, that is booming language, that is ML. Okay, so here this ML is also supporting this nested procedure declaration. So we'll see some the syntax and the semantics of ML now. So here we can see the language ML language declarations, and if you look at the first line, so here we can say that ML is a functional language. So when we say that functional language, it means that the variable, once it is declared and initialized, then that value or the variable cannot be changed. So this is why it is called as a functional languages. So but still there are few exceptions in that. That is, for example, when we are using array, then we can change the elements of array by using some special function calls. So that is the exception we have here in this. But other than this array, in ML, whenever we are using a variable, that is, we are declaring and initializing a variable, then that value or the variable cannot be changed here. And this is why it is called as a functional language. And this is the syntax for defining a variable. Okay, so if you look at here, this is the value. Okay, so here we are going to represent the value, and this is name of the variable, and in the right hand side we are going to use the expression for this variable. Okay, that is the value we are going to assign for this variable. And here in this expression, so it has int, that is the data type, along with the value or along with the expression that we are going to assign to this variable name. So this is the variable definition. Then here this third statement is about the function definition. So we can define the function by this syntax. So this is the function, and we have the function name here, and these are all the arguments. Okay, the arguments present inside the function, and this is the body of the function, so that is present after this assignment statement. So then when we say function body, okay, so we can also use the let statements inside this body. And what this let statement contains is it consists of list of definitions. Okay, the function definitions, and here we can say the statements. Here for this function definition we have statements, and this is the let statements, and this is of this form like this. So here when we are defining a function, so inside this body or inside this body or inside this definition, we can also have one more function. We can also define another function here. So that is why we are saying that the ML is supporting the nested procedure declarations. So next is the nesting depth. So when we say nesting depth here, for procedures without nested within another procedure, then we can say the nesting depth of that procedure is 1. That is, for example, when we have a procedure P. Okay, so and inside this procedure there is no other procedure that is nested. So we can say that the nesting depth of this procedure P is 1. And if there is one more case that we have another procedure Q, so this procedure is defined inside this procedure P, that is this is a nested procedure for on P, then we can say the nesting depth of Q is 2. So here based on that procedure, okay, so here we can define the nesting depth of the procedure, that is based on the nested procedure we can define the nesting depth of the procedures. And here the nesting depth for the nested procedure is I plus 1. That is for this procedure we have nesting depth I1, so which is taken as I here, and the nested procedure that is present immediately inside the procedure. So for this one here the nesting depth can be considered as I plus 1. So that's why we are getting the nesting depth 2 here. So this is the formula that we can use for the for finding the nesting depth of the nested procedure. So let us consider this example program. So this is the ML program. Here we have some procedures and nested procedures inside that procedure. So when you look at here in the first statement, we have procedure that is sort, and inside this procedure we have array. Okay, and if you look at the second line here, actually we are defining the array elements, and the first value represents the number of elements that is present in the array. And we know that basically array index starts from 0 to n minus 1. So here totally we can hold 11 elements in this array. And here the second argument of this array says that initially all the array elements are 0 here. Okay, so initially all the elements of the array is holding the value 0, and this choice of initial value can be given by the user itself. And here if you look at this value 0, this is an integer value. So here we no need to declare the type of value a here, the variable a here. Why? Because since this is integer value, so the array elements also array elements also contains only the integer type of values. And here the type of a is also an integer type. And here in the second line, and we have array declaration. And when you look at this fourth and sixth line, here we have array that is accessing the array. We are going to access the array a here. So inside the procedure read array and exchange. So here read array is one function and exchange is another function. And inside this function we are going to access this array, which is a global variable here. So that is, sorry, it is not a global variable. Actually, it is declared inside the procedure shard. So if you look at these procedures here, so here this read array, exchange, and this quick shard. Okay, these three procedures are actually nested inside the procedure sort. And when you look at this procedure partition, so this procedure is actually nested inside quick short, right? So here this partition is nested inside quick short, whereas this quick short, exchange, and read array, these three procedures are nested inside this procedure sort. And when you look at this procedure, so the nesting depth of this procedure is actually 1. And when coming to these three procedures, as these three procedures are nested immediately inside this procedure, so the nesting depth can be taken as 2 for all these three procedures. And when coming to this procedure partition, so this is actually nested inside this quick short. So for this partition procedure, the nesting depth can be 3. This is the continuation of the same code, and if you look at here in this 11th line, so here this is actually accessing the variables A as well as B, and again it is executing the partition procedure recursively. So you can see that this function actually calls itself recursively, right? And this is about this statement, that is 11th statement. Then coming to 12th statement, so here the outer function sort is going to access the variable A, and it is calling the two procedures, that is read array as well as quick short. Now we'll discuss about this access link. So previously we discussed about the issues with nested procedure. So whenever we are using the nested procedure, then it is not simple to access the variables, right? So that we are using in that procedures. So for that problem, we have a solution, and that solution is the usage of access link. So here we are going to see what is that access link and how we can access the variables of nested procedures without any problem. So here the static scope rule for the nested function can be obtained by adding a pointer, and that pointer is called as the access link. So we are going to add a pointer to each activation record, that is whatever the activation record that is present inside the stack, for all that activation record we are going to add a pointer, and that pointer is actually your access link. And so we'll see how we can add the access link for each and every activation record. And if you look at here, we have a procedure Q and a procedure P, and this procedure P is actually nested inside the procedure Q, and here the nesting depth for this Q is 1 and the nesting depth for this P is 2, right? So when we have this nesting procedure, that is if P is nested inside the procedure Q, then here the access link for this procedure P is actually pointing to the most recent activation of Q. Okay, so whenever we have the nested procedure like this, then the access link of this procedure P should point to the Q, activation of Q. Okay, that is the immediate or the recent activation of Q. So here is the example showing the access link, and if you see here, this actually forms the chain from the activation record. Okay, so it forms the chain of access link from the activation record at the top of the stack to a sequence of activations happening here. And so this is the stack which contains the activation record of procedures, and if you look at the procedures here, it starts from the procedure S, and we are taking the same example, that is the ML example that we have seen for doing quick shot. Okay, the same example I have taken here, and these names of the procedure, actually we are taking the abbreviated form of the procedure, that is quick shot for Q, and here P we are using E for exchange. So if you look at this procedure exchange, okay, so here it has the activation record and there is an access link for this exchange. So that is actually bypasses the activation record for the quick shot. Okay, that is you can see the access link for the quick start. Okay, so when you look at this access link, so it bypasses the partition as well as the quick start. Okay, so after that it goes to the sort that is nested. Okay, so here this exchange is actually nested directly within this shard, so it is immediately within the shard. So the here the access link is processing to the sort. Okay, so it is linking to the activation record of sort. And coming to here the partition, as this is nested inside this queue, we can have the access link. Okay, so that is towards the procedure queue, that is activation record queue. And the same way, if you look at these two procedures queue, and these two procedures are nested inside this procedure S, so we can see the access link that is flowing to this procedure S. So next is the display. So here when we are coming to display, is there is a problem with access link approach. So that is whenever we have the nesting depth that is getting larger, okay, then we may have to follow long chain of link to reach the data that we actually need. So that is a problem with access link approach here. So for that we have a more efficient implementation uses, that is the auxiliary array. So here we are going to use the auxiliary array D, so which is called as the display here. Okay, so this auxiliary array D is called as the display, and here we are going to use this efficient implementation of auxiliary array, and this consists of a pointer for each nesting depth. So for each and every nesting depth, so here we have a pointer to hold that position of that depth. Okay, so you can see the example shown here. If you look at this example, so this is the procedures activation record that is on the stack, and if you look at here, we have in previously we have the access link from E to S directly, and then we have an access link from P to Q and Q to Q. Okay, so like that we have access links, number of access links. And if you look at here, we have an array. Okay, so that is we are using an auxiliary array D. Okay, and this array consists of pointers, and each pointer is pointing to the procedures. So if you look at this D of 1, which is pointing to S, and if you look at this D of 2, it is pointing to this array, that is procedure, that is D of 2. Okay, so that is, for exchange we have the procedure D of, sorry, for the procedure E we have pointer D of 2, and it is pointing here, and this procedure contains D of 3, so which has a pointer over here, right? So likewise we are using the auxiliary array. So the main advantage of using this display is that whenever we have a procedure, okay, and that procedure is executing, and that procedure needs to access elements from other procedure, some other procedure, so at that time we need to look only in this D. So we don't need to look for the accessing links. Okay, so here we can just look at the based on the value of D here. Okay, so based on this pointer D, so we can access or we can follow the activation record of that procedure. Okay, so with that I mean with the help of this we can able to access the variables in some other procedure. So with the help of this display we are overcoming the problem that is happening with in access links.